Okay, in this podcast we're going to learn how to name chemical substances. Nomenclature is just a term that means to name. Okay, there are some chemicals that have common names that are different than their IUPAC names. IUPAC stands for the International Union of Pure and Applied Chemists, which is the governing body that decides how compounds should be named. And the chemicals that we want to name are, by their common names, are ones you're very familiar with, which is water, H2O, and the other is ammonia. So ammonia is one you got to memorize. It's NH3. We call it ammonia. We use it a lot, and it's not called nitrogen trihydride. All right. As you know, there are two types of compounds. Ionic. Ionic compounds are made from ions, which are atoms with a charge. They are ions that lose electrons, and those are called cations. They're either a metal, which will lose an electron, or ammonium, which is the only positive polyatomic ion. Or there are ions that gain electrons, and those ions are called anions, and they are nonmetals or any of the other polyatomic ions which are negative. So it's made from a positive ion and a negative ion. That positive ion is usually a metal, which is why we say you look to see whether or not something starts with a metal, and if it does, it's ionic. Technically, you can start with a metal, or you can start with ammonium. On the other hand, the other type of compound is a molecular compound, and they are made with covalent bonds as opposed to ionic bonds. In order to identify whether something is ionic or molecular, you need to be able to look at the periodic table and identify where the metals are. So basically, these are the metalloids along the stair step. Everything to the left of these are metal. Everything to the right of these are nonmetals. So if a substance starts with a metal, it's an ionic compound. If it starts with a nonmetal or a metalloid, it is a molecular substance. Now, one thing that's wrong here is hydrogen is actually a nonmetal. It is left of the line, but it is the exception. It actually should be yellow. It's a nonmetal. Yes, it's a nonmetal. Okay, so let's just take a look at these. So lead 2 chloride would be ionic because lead is a metal. Sodium iodide starts with sodium, which is a metal, so this is ionic. CH4 methane starts with carbon. Carbon is a nonmetal, so it would be molecular. Potassium nitrate starts with a K, which is potassium, which is a metal, so it's ionic. SO2, sulfur dioxide, starts with S, which is nonmetal, so it is a molecular compound. Ammonia starts with N, which is a nonmetal, so this is molecular. Magnesium fluoride starts with magnesium, which is a metal, so that would be ionic. And water starts with hydrogen. As we said, it's a nonmetal, so this is a molecular compound. Okay, so let's make sure we know how to do that. That's key to knowing how to name, because molecular and ionic compounds are named differently. All right, so let's first going to talk about naming molecular compounds, and here's just a few examples of molecular compounds. They are all formed from two or more nonmetals, as opposed to ionic compounds, which are generally formed from a metal and a nonmetal. Molecular compounds, sometimes called covalent compounds, form from two nonmetals, and we use the prefix system to name those. This is primarily for binary compounds. Okay, when we write a formula for a molecular compound, we generally will list the least electronegative atom first. Now, we haven't talked about what electronegative means, but the basic rule then is whatever element is to the leftmost on the periodic table gets listed first, followed by those that are further to the right. So you just basically follow the order of the periodic table. So if I have two elements, I want to list the one that's furthest to the left first. We add prefixes to indicate the number of atoms, and we omit the term mono. Mono means one, but if the only exception to this rule of using these prefixes, if the first element, there's only one of them, we omit the mono. And we change the ending of the second element to "ide." So instead of saying sodium chlorine, we say sodium chloride. Okay. So here are the prefixes, and you do need to know these. So if it says mono, that means there's one, di is two, and so on. Alright, so let's practice some. So I have CCl4. I've got one C, so it's carbon, and 4 chlorines. 4 of the prefix is tetra, so this is carbon tetrachloride. And then I have 2 nitrogens, so this is nitrogen, dinitrogen, because there's 2, monoxide. Okay, so it's monooxide. I dropped the double vowel, so it's dinitrogen monoxide. Alright, SF6, it starts with sulfur. There's one of them, so it's going to be sulfur. I dropped the mono for the first one. And the 6, the prefix is hexa, so it's sulfur hexafluoride. Okay, and I can go the other way. Arsenic trichloride. I just basically list what it says. So the symbol for arsenic is AS. Trichloride tells me that there are 3 chlorine. Dinitrogen pentoxide tells me there's 2 nitrogen, 5 oxygen. Tetraphosphorus digoxide tells me there are 4 phosphorus and 10 oxygen. Alright, so let's do some checks here. Fill in the blanks to complete the following. Carbon, this is 1 oxygen, so it's going to be monoxide. CO2, whoops, sorry about that. CO2 is going to be carbon dioxide. PCl3 is going to be phosphorus trichloride for the 3. CCl4 is going to be carbon tetrachloride. N2O is dinitrogen monoxide. Alright, P2O5, I'm going to pick which one is going to be. You can try it first. So P2 means diphosphorus, the 5 is pentoxide, so it's option C. Cl2O7, this is dichlorine, okay. There's 2 choices here for dichlorine. 7 prefix is hept, so it's dichlorine heptoxide, which is 8. And this is just an element. It's not a compound, so we just name it with the element name. It just happens to be diatomic, so this is chlorine. Alright, so we're going to stop there because now we're moving on to ionic. That will be the next podcast.